Alright, so now we have inverse variation, and in this case we just did an nth power. If it was just a regular variation, the only difference is y over kx, like this. And that just means varies inversely. So directly we had straight across, y equals kx, and now we talk about inversely. Alright, so inversely just means that we're going to have y equals k, and the x is on the bottom. Directly it was straight across. Inversely we now have this format. But the process is still the same. You start with your equation and then we plug in the first two values. Y is 32, x is 3. We're solving for k. Now in this case we're going to cross multiply. Put this over 1 and we're going to cross multiply. 32 times 3 is 96, and then 1 times k is just k. So find your k. Write the equation again, just like we did in the past, and we'll plug in k. So y is equal to 96 over x, and then you finish out the problem. Find x when y is 15. So they say y is 15, find x. And then we cross multiply to solve this. So I would say 15x is equal to 1 times 96. It's 96. Solving for x, so you would divide both sides by 15. X is equal to, reduce that, divide a 3 out of both of them, and you get 32/5. Okay, so our process didn't change much. Our original equation did because it was an inverse. Alright, so number 6, we're working with an inverse variation, an inverse proportional. So the equation we're comfortable with is y equals k over x, but we're going to convert it over to use variables that are in our word problem. It'll say if the electrical circuit is inversely proportional to the resistance, okay, so we'll have A is equal to K over O, which is ohms. So these are just amps and ohms in respect to circuits. So it doesn't matter, we'll just be consistent. If the current is 80 amps, we let A be for amps, so 80A. We're looking for K, and the resistance is 50 ohms, so 50 ohms. Cross multiply to solve. So here I would say 80 times 50 is 4,000. If this is over 1, I would get 1 times k is just k. So once again, we write our equation a second time and we fill in k. So I'm going to say A is equal to k is 4,000. Then we go back to our problem. Find the current when the resistance is 22 ohms. So I know the ohms is 22, and it says find the current. So we're looking for the amps. 4,000 divided by 22. You can reduce by 2 and get 2,000 over 11, or you can divide that out. So we would get 2,000 over 11, or approximately 181.81 with the bar over it amps. So you could leave it as a fraction, or you can go ahead and divide it out and get a decimal. And the last variation that we're going to talk about today is going to be a joint variation. You can see y varies jointly to the nth power of x and z. So you have multiple variables basically. The y equals k, and the x is going to be custom, and then the other variables are added in. So for example, my original would be y equals k x z. Y equals kxz. Y varies jointly, jointly means together, as x and z. Okay, so y varies jointly. Of course, the k is always in our variation problems. That's our constant term, and then it says as x and z. So it just says we're going to have more than one variable. Okay, we have our equation, and the process is plug in the first values. Y equals 33. The k we're looking for, x is 9, z is 12. Multiply 9 and 12 and you get 108. Keep the k up there. And then to get k by itself, divide both sides by 108. Divide a 3 out of both of those and it reduces to 11 over 36. Alright, once we find our k, we always write our original equation down and plug in k. So k was 11 over 36. And then we go back to the problem to plug in the rest of the given information. X is 16. Z is 22. Find Y. And at this point, we're just going to multiply everything on the top. So if you wanted to put these over ones, you would say 11 times 16 times 22. And then put that over 36. That would be 3,872 over 36 times 1 is 36, and then you would divide a 4 out of both of these, and then you would get 968 over 9 as the fraction. And so we finish this last one up with a word problem. Kinetic energy varies jointly as the mass and the square of the velocity. So first of all, jointly, let me just recall to myself, jointly is typically something with k and then multiple variables. Now I'm going to pick some letters that match our word problem a little bit better. So I would say E, kinetic energy, varies jointly. The k is custom. Okay, so it's going to be there as the mass and the square of the velocity. So the square of the velocity. So we just changed the variable so that it matches our word problem. I'll pull that E for energy, varies jointly is equal to k. M for mass, velocity squared is the v squared. Alright, our next step is to plug in information. 8 grams is our mass. The k we're always going to be solving for. Velocity here is 5. Velocity is 5. And the energy is 100. Now let's clean up the algebra on this. So we're going to say 100 is equal to k times 8. 5 times 5, or 5 squared, is 25. 25 times 8 is 200. To get k by itself, we're going to divide both sides by 200. And then if we reduced, we would get 1/2 is equal to k. We always start with our equation again. And we plug in our k. We always start there. Then we go back to our equation to see what they tell us. Find energy. So we know we're looking for energy. When a mass is 6, velocity of 9, and we got to remember to square it. So we're just going to go do some, clean up this algebra a little bit, bring down 1/2, 6, 9 squared is 81. So this is over 1, this is over 1. 1 times 6 times 81 is equal to 486, and then I have 2 times 1 on the bottom, which is 2. I divide that out, 46 divided by 2, and we should get E is equal to 243. And that's going to be our energy.